And today we're going to be replicating Eratosthenes' famous measurement of the Earth. So the first thing we have to take into account when we do this is that at the time Eratosthenes knew the distance between two cities to base his measurement on. And they did this by knowing latitude. And so to start our experiment, we took the latitude of the Tropic of Cancer, which we know to be 23.5 degrees north, and we took the latitude of here, which is roughly 42.74 degrees north. So we take the difference of those, multiply them by 111.2 kilometers per latitude, and we get a distance of about 2,140 kilometers from the Tropic of Cancer. That's the first point we need. Now the next thing we need to do is measure the zenith of the sun at this time of the year. Now, to get the accurate answer for this, you need to do this during the summer solstice, but obviously it's approaching winter in Michigan, so our number will be somewhat off because of that, but it's alright. It'll be fairly close. So the next thing we need is some type of cylindrical object. Anything works. Using a can of hairspray today, thanks to Arnold over here, Mr. Cameraman. So the first thing we're going to do is measure the length of the hairspray can, and it's roughly 6 inches. Now the next thing we're going to do is measure the shadow that the can makes. Obviously, it's not an extremely sunny day today, but we're doing the best we can. It's Michigan weather. So, measuring the length of the shadow, and you have to make sure you come from the center of this arc right here, because these shadows aren't actually part of the length of the shadow. So this turns out to be, we're going to say, for the sake of estimate-wise and easy numbers, about 2.5 inches. So that was 6 inches for the length of the can and 2.5 inches for the length of the shadow. So the next thing we need to do, and this Eratosthenes found out by geometry, we take the arc tangent of the shadow length over the length of the can to get an angle. So we're going to do this real quick. Obviously they were better at math in their heads than I was, but it's easier to use a calculator for me. So arc tangent of 2.5 divided by 6 gives us an angle of roughly 22.6 degrees. So the next step of the calculation, to find the circumference of the Earth, we take 360 degrees, or the full circumference of a circle, and divide it by the angle we just got, which is 22.6 degrees, and we multiply that by the distance from the Tropic of Cancer to here. So we're going to do that. 360 divided by 22.6 times the 2,140 kilometers we got before, and we get a number of about 34,088 kilometers. The actual circumference of the Earth is about 40,075 kilometers. And obviously we're not getting a correct number because we're doing this not during the summer solstice. But if you were to do this during the summer solstice, this number would be accurate because all of his geometry is correct. So that was Eratosthenes' experiment. Thanks for watching.